To understand the engineering used in the lamp spring, we came to the University of Illinois to meet Professor Bill. In 1870, Thomas Edison invented the lamp. Of course, many say that the invention is not Thomas Edison's, but that is not related to this video. This invention is registered under Edison's V. You might find it interesting to know that Edison's original choice for the filament inside the lamp was bamboo. However, bamboo couldn't work for a long time. The bamboo filament would either burn out or burn. Other scientists in the 20th century discovered that lamps to work longer. Instead of bamboo, we use tungsten, which is still used in incandescent lamps today. Now I want to remove the glass of this lamp so we can clearly see inside it. When you zoom in on the lamp's filament, you see that it's a coil. But not an ordinary coil. A coil made by twisting another coil. The wire that the lamp's filament is made from is 20 inches or 50 centimeters long. The tungsten wire is first wound into a narrow, small coil that becomes 3 inches or 7.5 centimeters long. This 7.5 centimeter coil is wound again into a coil, becoming 3.4 inches or 1.9 centimeters long, and is installed inside the lamp. Now, why does the wire used to make this coil need to be so long and shaped this way? Because if you simply weigh a tungsten wire, it will light up in the lamp but won't emit any light. That's why they use a 50 centimeter wire to make its light noticeable. And to fit this long wire into the bulb, they turn it into a double coil. The bulb distributes the light of the 50 centimeter wire. This sheet is like that. Do you see how easily it plays? But tungsten is not playful at all. Tungsten is one of the strongest metals in the world. That's why it's very brittle and breaks easily. And this is a tungsten sheet. It breaks when bent. Now the question arises here, how do they make such a brittle metal so springy without it breaking? First, they heat a tungsten to 1300 degrees Celsius and cool it with water. Then they connect it fans to electricity. This time they heat it to 3200 degrees and cool it again with water. They heat it again, this time to 1500 degrees Celsius, and the cooling is no longer done with water. They cool it with hydrogen gas. Then they stretch and pull it under pressure. Then for the last time they heat it and completely turn it into wire. This wire is now ready to go into the bulb. Now it needs to be coiled. Once it is coiled, it is installed inside the bulb, but you can't connect the electric current because it will burn out immediately. To prevent it from burning out, we need to ensure that oxygen doesn't reach it, so they create a vacuum around it and fill it with argon gas to make the tungsten last longer. You might ask why they don't create a vacuum inside the bulb? Because doing so would make the process more difficult. Oxygen is removed, argon takes its place, and the process is easier. The lifespan of the point is also extended. However, in recent years, these bulbs are gradually being phased out and LEDs are taking their place. But the interesting point is, for us to understand the engineering involved in this small task and how this tiny coil was made,